talking about hyperbolas. This video is about hyperbolas. Not hyperbole, but hyperbola. And hyperbolas are one of the coolest things in the world. And that is not a hyperbole. But let me tell you what a hyperbola is. It's a shape we can make on the Cartesian coordinate system. It looks like this. It's got foci, call this F1, F2. It's got vertices, call this V1, V2. Okay? And very similar to the ellipse. It's got an x squared and a y squared involved with it. But instead of a plus here, it's a minus. Furthermore, this is one version, or you get this version. So notice, unlike the ellipse, the A has to go where the positive term is. So that's one thing that's different about hyperbolas, about the ellipse. The ellipse would have the a squared under the major axis, but here the a is under the positive term. So this equation up here would give us a hyperbola that looks like this, with vertices over here. This would be at negative a0, positive a0, and foci at negative c0, positive c0, and let us find out how we can determine what c is. With ellipses, c squared used to be a squared minus b squared, but now we have c squared is equal to a squared plus b squared in this case. Okay? That's the difference. Okay? So to be able to solve for c, c is equal to plus or minus the square root of a squared plus b squared. And similarly, if you had one in this format, your hyperbola would look like this. It would just be opening about a different axis. You get this here, it'd have a focus, okay, it'd have vertices. It would look the same, it just opens up differently. Okay? Due to some technical difficulties, these videos will be done with shortened board space. And so I'm going to have to delete this information here and write some more stuff. Alright. Let's do some problems where we actually find the vertices and the foci from an equation. So how about x squared divided by 16 minus y squared divided by 9 is equal to 1. As I said, the a squared is always in front of the positive term. So a squared is equal to 16. This implies that a is equal to plus or minus 4. B squared is in turn equal to 9. This implies that b is equal to plus or minus 3. Alright, so what is c? Well, let's plus or minus something. Remember, c was in this case, it was defined to be c squared is a squared plus b squared. And so c is going to be plus or minus the square root of a squared plus b squared, which is 16 plus 9. This gives me plus or minus the square root of 25. This equals plus or minus 5. So our c is located at plus or minus 5. Notice that the positive is on the x, and so we got a hyperbola that opens up like this. The foci is here at 5, 0, negative 5, 0, and the vertex here is at the a, negative 4, 0, and over here, positive 4, 0. So there you have it. That's how you graph a hyperbola that is opening about the x. We might want to graph another hyperbola that maybe opens about the y. Okay. Let's delete this here. Let's delete this here. Now let's try y squared over 9 minus x squared all over 16 is equal to 1. Again, notice that the a squared is on the positive term, and notice that a is no longer strictly larger than b, in which that was true when we dealt with ellipses. So notice here that a squared is equal to 9, implying that a is equal to plus or minus 3. Notice that b squared is equal to 16, which implies that b is equal to plus or minus 4. Notice that c squared is equal to a squared plus b squared, which implies that c is equal to plus or minus the square root of 16 plus 9, which, matter of fact, we found that last time to be plus or minus 5. Okay, so here we're going to get a hyperbola opening about the y-axis here, with a foci here, with a focus here and a focus here. The foci are located at 0, 5 because of the y, 0, negative 5. The vertex here will be located at the A. This is going to be 3, 0, 3, and 0, negative 3. Okay? So, there you have it. This is how we deal with hyperbolas and how to graph them. There is some more information with regards to hyperbolas, and that is about their asymptotes. Notice that a hyperbola, when we draw it, okay, like this, and like this, and like this, and like this, we can actually establish kind of a fancy situation here. A fancy situation here occurs when, oh, this says no ink, go in the trash. Over here, here's our fancy situation. We can create this square inside here, and notice that upon creating this square, that lines that go through the edges of the square behave as asymptotic lines to the hyperbola. Now, I'm not the best artist. This one doesn't really look close to it, but this one really does look like a nice asymptotic line. Not so much here, but definitely here. It does kind of look like an asymptotic line. Notice that these asymptotic lines, whenever you have them in the x squared over a squared minus y squared over b squared is equal to 1 format, your lines, your asymptote lines here are actually equal to y is equal to b over a x for this guy, and y is equal to negative b